All right, geometry students, welcome back. We're continuing on in our deductive reasoning, facts over feelings, we like to say. Yesterday we talked about the law of detachment. If P implies Q is true and P is true, then Q is true. Today we're going to be talking about the law of syllogism. Another way to make a valid conclusion is to use the law of syllogism. It allows you to draw conclusions from two true statements when the conclusion of one statement is the hypothesis of another. So I like to talk about this in terms of P, Q's, and R's. So if P implies Q is true and Q implies R is true, then P implies R is also true. So what we're saying is P implies Q, Q implies R, then we can go from the beginning. P implies R. Sometimes we like to call this transitive property in math. So the two conditional statements below are true. Use the law of syllogism to find a valid conclusion. State the conclusion. So number one, if a number is a whole number, then the number is an integer. Number two, if a number is an integer, then it is a rational number. So our P statement, I like to put this here, so we'll say our P statement is a number is a whole number. Our Q statement, a number is an integer, and a number is an integer here. And then our R statement is a number is a rational number. So P implies Q, and a number is a whole number, then it's an integer. And if a number is an integer, Q implies R, then it's a rational number. So P is a number is a whole number. Q, a number is an integer. R, a number is a rational number. So what we can say is this. If P implies Q is true, Q implies R is true, now we can go from P to R. So P to R. So our statement is going to be if a number is a whole number, then it is a rational number. So if a number is a whole number, then it is a rational number. So that's called syllogism, the law of syllogism. Syllogism. Say that a couple times fast. So we have 5 problems, and again, just like yesterday, I'm actually going to do them with you, but I expect you to pay attention, and I expect you to write the answers down on your own and submit your work. So I'm not going to write the answers for you in what you're submitting. So you have a blank copy just as I have a blank copy, and I'm going to write these down, and we're going to go through it. So use law of syllogism. We're going to determine if we can make a valid conclusion or not. If there's no valid conclusion that can be made, then we just say no valid conclusion. So if a dog eats superfood, he will be happy. So P, a dog eats superfood, he will be happy. Q. Rover is happy. R. So what's going on here is we need to make a conclusion here, a valid conclusion. So if a dog eats super dog food, he will be happy. Rover is happy. So do we really have enough information to say that Rover is happy because he ate super dog food? The correct response is no, we don't have enough. We don't have enough information here. Rover could be happy because he's getting a stick thrown and he's playing fetch. He could be playing catch with a ball. So there is no valid conclusion here. So no valid conclusion. So that's what we're doing here. Now let's look at this one. If an angle is supplementary to an obtuse angle, then it is acute. If an angle is acute, then its measure is less than 90 degrees. So our P is this here. If an angle is supplementary to an obtuse angle, Q is it's an acute angle, right? And we know that to be true by definition of supplementary angles, and acute and obtuse. So P implies Q. Now we have Q is an angle is acute. And then we have our R statement here. Then the measure is less than 90 degrees. R. Well, are acute angles less than 90 degrees? Because we have P implies Q is true. So P implies Q is true. And then we have Q implies R. Q implies R. Is that true? If an angle is acute, then it is less than 90 degrees. Well, yes, because that is the definition of an acute triangle. So now we have P implies Q is true, Q implies R is true. So P implies R must be true. So now we're going to write this. P implies R. So P was P, if an angle is supplementary to an obtuse angle, that's our R, then, or that was our P statement. Now we're going to write our R statement. Then R, its measure is less than 90. And that is our valid conclusion for that problem. Now let's do 3. If the measure of angle A is less than 90, so that's P, then angle A is acute, that is Q. If angle A is acute, that is Q again. Then angle A is congruent to angle B. That's our R statement. So we have to think about this. Actually, I'm going to change that to a different color for R. We'll do that in blue. So that's our R statement. So if the measure of angle A is less than 90, then A is acute. That is true. So P implies Q is true. True statement. Now we're going to have to look at Q implies R. Q implies R. So if angle A is acute, then angle A is congruent to angle B. We don't have anything that tells us that that can't be true. So this is a statement, and it's telling us if angle A is acute, then angle A is congruent to angle B. So we've already been told angle A is acute. It is acute. So now the conclusion is angle A is congruent to angle B. So we have to say that that is a true statement. So now, since we have P implies Q is true, Q implies R is true, we are left with P implies R. And so we're going to write that as our text. We're going to write that if P, the measure of angle, and I'm going to write angle A is less than 90, then R, angle A, is congruent, and I don't have the symbol for congruent, so I'm just going to put equal to angle B, and that's our statement. And then I'll come over here and I'll draw in the squiggly for us. Then angle A is congruent to angle B. So if P, the measure of angle A, is less than 90, then angle A is congruent to angle B. And that's our statement. So it helps really to write down what our P is, what our Q is, and what our R is. If an angle is a right angle, that's our P. And then we'll do green for Q. Then the measure of the angle is 90 degrees. That's Q. If two lines are perpendicular, okay, then they form a right angle. So we're kind of working a little bit backwards here. So I had to look at it. If two lines are perpendicular, that's actually going to be a R statement. R, and then they form a right angle. But if you notice, the right angle means that's our P statement. So we got to unpack this one together and see what type of conclusion we can make. So this is working backwards, actually. This is if R implies P, we're working backwards. R implies P, and P implies Q. Then we're going to see if we can say R implies Q. So let's break each of these statements down and see if they're true or false. If two lines are perpendicular, R implies P. If two lines are perpendicular, then they form a right angle. Well, we know that. That's the definition of perpendicular lines. They form 90-degree angles, right angles. So we know that is true. So R implies P is true. Now let's do P implies Q. If an angle is a right angle, then the measure of the angle is 90 degrees. Well, the definition of a right angle is that it equals 90 degrees. So we know P implies Q is true. So from that, we can say R implies Q is true. So we're going to go ahead and write that now. R implies Q. So R, if two lines are perpendicular, then they form a right angle. And that's our statement. Last one. Let's see what we got. If you study for the test, then you will receive a high grade. Your grade on the test is high. So we have P is if you study for the test. Q is you will receive a high grade, and R is your grade is high grade on the test is high. So we have P implies Q, and then we have R. We don't have R implies Q. We don't have Q implies R. Now, if this says your grade on the test, that would actually be Q. So we have P implies Q, and then we're given Q. So really, all we're looking at here is we really don't have enough information to really do anything with this. So since we don't have enough information to do anything with this, because your grade on the test is high, well, it could be because you just knew the material, not because you studied. You could have got lucky. It could have been multiple choice. There's so many different factors, so there's no valid conclusion here. And that's it. That's deductive reasoning with the law of syllogism. Good luck. Remember, it is your responsibility. I did the problems with you. It is your responsibility to write your answers in and submit your work. Thanks, guys. Have a great day.